Hello everyone. Welcome to our tutorial on TypeScript basics. Today we're diving into 3 fundamental concepts that will help you write more robust and maintainable code. First up, let's talk about what TypeScript is and why it's so useful. Then we'll explore different types of data you can use in your TypeScript projects. Next, I'll show you how to define interfaces, a powerful way to describe the shape of objects. After that, we'll create type aliases, which are a handy shortcut for defining complex types. Finally, we'll see these concepts in action with some practical examples. By the end of this tutorial, you'll have a solid understanding of TypeScript's core features and be ready to start building better applications. Welcome to our introduction to TypeScript. Imagine JavaScript with superpowers. That's what TypeScript is all about. It's like adding static typing to your JavaScript code, making it a superset of the language. This means you can gradually add types as needed without breaking existing scripts. By doing this, TypeScript helps catch errors early in development, saving you time and headaches down the line. Plus, since TypeScript compiles to plain JavaScript, it's super easy to integrate into your current projects. It supports all those fancy modern features while also making your code more organized and easier to maintain. So whether you're working on a small project or a large-scale application, TypeScript can be a game-changer for your development workflow. Hey there! In this slide, we're diving into the heart of TypeScript's powerful type system. First up, primitive types like number, string, and boolean. These are your basic data types. Next, arrays and tuples. Think of an array as a list where every item is of the same type, while a tuple lets you mix different types in one. Then we have union and intersection types. Union types let us describe values that can be one of several types, like number or string. Intersection types combine multiple types into a single type, giving us more flexibility. Moving on, optional properties allow some fields to be omitted when creating objects, while read-only ensures those values stay the same once set. Finally, type assertions are there when you need to tell TypeScript that your data is of a specific type, even if it doesn't look like it at first glance. This gives us more control and helps catch errors early on. Stay tuned for more in our TypeScript series. Welcome to our lesson on primitive types in TypeScript. As we dive into the basics of TypeScript, let's look at how these fundamental data types are used. Here's a quick example. This line declares a variable called age and assigns it the value 25. The type here is number, which can be any real number. Next up, this creates a variable named name and sets its value to the string John Doe. Lastly, we have where isStudent is of type Boolean, meaning it can only be true or false. These are just 3 examples of primitive types in TypeScript: numbers, strings, and booleans. Each has a specific purpose, making your code more readable and maintainable. Welcome back to our journey into the world of TypeScript. Today, we're diving into interfaces. Think of interfaces as blueprints that describe the shape and structure of objects. For example, if you have a user object with properties like name, email, and age, an interface can define this exact structure. Interfaces are super useful because they ensure consistency in your code by checking that all objects conform to these defined structures. You can use interfaces with classes or as standalone types for more flexibility. They're also a lifesaver when it comes to refactoring, since TypeScript will help you catch any mismatches. Let's take a look at an example. Imagine defining a user interface with properties like name, email, and age. This way, whenever you create a new user object, you know exactly what properties are required. Welcome to our journey into the world of TypeScript. Let's dive right in with interfaces. An interface is like a blueprint for objects, defining their structure and properties. On this slide, we see an example of an user interface defined using types. It has an ID, which must be a number, a mandatory name property that should be a string, and optionally, you can add an age. Now let's look at how we use this interface in the code. Here, we create an object called user, adhering to the structure defined by our user interface. This means we must provide both ID and name, but we could also include or exclude age based on our needs. This way, TypeScript ensures that any variable declared as a user strictly follows these rules. Hey there! Welcome back to our TypeScript Basics series. Today we're diving into type aliases, which are super handy for giving complex types more descriptive names. Imagine you have a union type that includes string and number. You can wrap it in a type alias like this. Type color equals red, green, blue. This not only makes your code easier to read, but also maintainable because if you need to update the color options, you just do it in one place. Plus, type aliases work with unions, intersections, and tuples, giving you immense flexibility. For example, type point equals x, number, y, number, e number, number. This way, you can use point either as an object or a tuple without duplicating the logic. So, next time you're writing complex types in TypeScript, consider using type aliases to keep your code clean and maintainable. Welcome to our journey through the world of TypeScript. Today, we're diving into type aliases. Essentially, a type alias is a way to give a complex or compound type a more descriptive name. Look at this example. Here, we've created an alias called that represents one of three possible values: red, green, or blue. This makes our code clearer and easier to understand. Now, let's see how we use it in a function. In this function, we're passing in two parameters: the element we want to style and its color. The second parameter is of type. We then set the background color using this alias. For instance, we can call with an HTML element and the string red, which will change the background color of that element to red. This not only improves code readability, but also helps in maintaining consistency throughout our application. Alright, let's quickly review the key takeaways from our session on TypeScript basics. First off, TypeScript adds static typing to JavaScript, which means we can catch type errors during development before they become big issues in production. Second, interfaces are like blueprints for objects. They define their structure and ensure that all instances adhere to this blueprint, maintaining consistency throughout your code base. Third, type aliases allow us to create custom names for existing types, making our code more readable and maintainable. Lastly, these three types, interfaces, and type aliases are powerful tools that work together to help you build robust TypeScript applications. Each one plays a crucial role in keeping your code organized and error-free.